Hey everybody, welcome back to another ArcGIS tutorial with me, Skip. In this video, we're going to cover making heat maps in ArcGIS Pro, and we're going to do it with two different tools. We're going to do it first with the kernel density tool, and we're going to do it second with the point density tool, and we'll talk about some of the differences as we get there. What you see shown here on the map is a list of all the tornadoes in America since 2020. Well, 2020 to 2023, so it's a little bit outdated from when I'm making it. So it's even a little bit more outdated when you're watching it, but it's a bunch of tornadoes, 3 years worth. What I want to do is I want to make a heat map of these tornadoes. So the first way we're going to do this is with what's called the kernel density tool. So in your geoprocessing search, if you type in kernel density and click, you're going to open up that tool. The input point or polyline features, that's going to be the points here, the tornadoes that we want to calculate this over. The population field, that's an interesting one. We're going to go with none for now, and we just want to plot where the tornadoes are. Where are the hotspots of just tornadoes in general? So we're going to leave this at none. For output raster, you're just going to name the output. So we're going to call it kernel density ID, whatever, and we're going to put no pop, so we know it's our one with no population. And we're going to leave the output cell size default for now, and we'll explain that a little bit more here in just a minute. Rest of these features are all optional. Here in our search radius, it's how far out it's going to look from each point to find more to make that density. For output cell values, we have densities or expected counts. We're going to go with densities now because we don't need to interpolate. We don't need any expected counts because we know where they all were. We just want to see the densities plotted out. And we're going to do this in a geodesic fashion here. And that is all we're going to need to set up for that. So the advantage of using a kernel density right is it's going to estimate the density of all these features in a region, and it's going to give us a smoothly curved surface that's fit over each point. It's going to be darkest where there's a higher concentration, and it's going to decrease with distance away from tornadoes. So let's go ahead and run this tool. It's going to take just a minute here. The kernel density is going to be a little more computationally heavy than the point density, but yeah, here we go. So if we zoom in here, we can see our densities of tornadoes. So you can see they're not very dense over here, so it doesn't even get to have much color to it. But as we get here into what's considered Tornado Alley, we see a lot more. Now this is a good time to talk about the output cell size that we had here. We can see that when we zoom out, this looks kind of okay. Let's turn off these points. We see it looks sort of fine, but it also looks sort of blocky and pixely. That's because of our cell size. So let's run this one more time with a smaller cell size. So here's our points again. Let's run this again. Let's call this no pop 2. And we're going to do a cell size of, let's say, 0.1, about half of what we were at before. We'll run the tool again. And now we can see, if we turn off our points again, it's a bit more smooth. So you can tweak that value to your liking for whatever it is you're trying to display to make sure it looks good in your presentation, your printed product, whatever. Just know that the smaller this cell output size, the smoother the curve is. So I said I'd explain this population field. What we've done here, let's go ahead and delete these. We don't need those anymore. What we did was we plotted and showed the density of just a tornado happening. But what if we wanted to know the population of like a big, the density of big tornadoes, a heat map of where a big, large, devastating tornado is going to come in? Well, if we inspect this data here, I have this field called mag. And what this does is it shows me the magnitude of all the tornadoes. And it's looking a little funny here because it shouldn't have negative values. Let me try something here. Let me put these out here. This is actually going to be 1950 to 2023, all the tornadoes now, which is going to be a bit excessive. But if we inspect this, now we see our magnitudes seem to be normal, but what's interesting is, let's look at the new data for it. So the magnitudes are a little wonky. Okay, so for sake of displaying this properly, let's just grab some old tornadoes. We're going to say select all of them where the year is less than 2000, apply, okay. And let's just pull this out as its own layer. Make layer, turn this off. Go ahead and close this. Let's inspect this here. Okay, all of our magnitudes look good. Let's go ahead and sort this descending. The max is 5, which would be a F5 tornado. Our lowest here is a 0, which is, I guess, just not a very big tornado. Let's only go with ones that are magnitude greater than 1. Let's do that too. So we'll make another selection where mag is greater than or equal to 1. Okay. All right, so now we've done a little bit of bookkeeping, so the video is going to go a little bit long, but I think that's okay. All right, so now we have a layer of all these tornadoes, a bunch of them, that all have some sort of magnitude applied to them. And we want to find where is the density of big tornadoes. So we want to make sure that each of these points, if it's like a 5 magnitude tornado, that it's worth 5 magnitude 1 tornadoes, because it's a lot bigger. To do something like that, we would just change. All right, let's go ahead and pick our new layer we got. Okay. For population field, we're going to select that magnitude. And so it knows now that the bigger the number, the more it needs to be counted. So now we'll change this to pop, and we'll run everything the exact same way as before. And now we can see that our map looks a little bit different. We see the more stronger tornadoes are down here, lighter is up here. Now it's going to be a little different because we're using a different year range of tornadoes. But you can see now, like if we were to, let's just run it. Let's run it with no population field. Okay, run. Okay, so this is what we have. And now we need to rename this and run it with the population on magnitude. And it looks similar, but just a little bit different. So you can see here, when we do it by population, we have, you know, it's relatively light right here. It's like the third color maybe, but when we do it by no population, it's more magnitude-y. So it is slightly different. So that's how you can do it if the counts of things are actually important. You just set a population field for what needs to be counted more, and you run the tool. So let's talk now about the point density tool. We'll get rid of these. We'll go back here. And we search point density. Very, very, very similar. Input features, we're going to use the same one we just did, the 1950 to 2023. I think we just did it 1950 to 2020. Doesn't matter. We have our layers. Again, population is none, but here it's asking us for a neighborhood. And so what this does here is with point density, you're calculating the density of points within a specified neighborhood around each like cell that's going to be generated, because we have our cell size, right? So that's how far it's going to look. And then you're looking in a region around that, and then it's going to start counting and making your density map. So let's just leave these default here and see what this gives us. Okay, we turn this, we turn off our points, and now let's look at our heat map. You can see it's very pixely. First off, I should have left up the kernel one, but we can see here that like these areas in here aren't necessarily as accounted for because they were more spaced apart. If we shrink this cell size down to be similar, and we run this again, it's going to give us a smoother outcome, but it's still a little bit off. But then we can play around. We'll go ahead and leave this on, but let's play around with the neighborhood size. Our radius was 2 map units. Let's say we wanted to search 10 map units around. We can run that. And I didn't change the name, so it's probably going to overlap. There we go. Run. Now it looks much different because it's searching farther and farther around to make those densities. So what happens if we, instead of 2, we make this 1? Well, let's run it again and take a look. So now we have, let's turn this off here. So now we see that it's a little bit more refined than it was when we did it here with the default. Everything's sort of tighter towards the denser areas. So the key differences here, right, between these two, we did kernel density and we did point density. Kernel density, right, gave us a smoother continuous surface over the area, spreading the density values based on that kernel function, while the point density is just a straightforward count of points in a neighborhood, giving you a less smooth surface. Computationally, the kernel density is more complex due to the way it's calculated, and point density is much simpler. So if you're running low on computational power, go with point density if you can afford to just have the counts in the neighborhood. But if you need something smoother, a little bit broader pattern and trend analysis or identification, that's where you're going to use kernel. The time you'd really want to use point is if you need to see granular, more exact concentrations. Now, one more thing I want to touch on here, if we open up this one, you can see that our points like cut off over here. And that is because we had no points that were more north of this line. We had no points that were south of over here, or it's off the map, but just because we have territories over there. And we have no points that are beyond out here. So it will bound your stuff to where your points min max at. So that explains why you get that hard line. So yeah, that is how you generate a heat map in ArcGIS Pro. If you like this video, be sure to like and subscribe. If you have any questions, comments, concerns, whatever, drop those in the comments. And I will leave you to figure out how to symbolize this as a heat map with your varying different shades of green to red or just red or whatever. We stuck with the purple for now. I'll do a video on symbology later. But anyhow, that is it for this video. Hope you enjoyed. See you next time.